Everybody, it is Jono from Seneca here, and today I am going to be getting hot and then I'm going to be getting cold because I am talking about enthalpy changes for your A-level chemistry exam. So, for any given process or reaction, we can measure an enthalpy change. Well, what's an enthalpy change? I hear you ask. Well, an enthalpy change is a measure of the heat given out or taken in during a process. When objects are heated, they use energy to expand. Enthalpy takes into account the energy used in this expansion. So enthalpy versus energy changes. We use enthalpy instead of energy because we cannot easily measure energy changes. This is because objects expand when heated. To measure an energy change, you would have to fix the volume of the object. Enthalpy is much easier to use as it allows for expansion. Enthalpy changes are instead measured under constant pressure. The atmosphere is at a constant pressure, so we require no extra equipment. Great. Next, we need to talk about endothermic versus exothermic reaction. An exothermic reaction is one that gives out heat energy and has a negative enthalpy change. So exothermic, negative. An endothermic reaction is one in which heat energy is taken in, and endothermic reactions have a positive energy change. A good example of a exothermic reaction is combustion, because combustion is an exothermic process and gives out loads of heat. So think of like a fire, that's exothermic. And so if we were to burn methane, we'd produce carbon dioxide and water, and the enthalpy change is about minus 900, and it's negative because it's exothermic. An example of an endothermic reaction is thermal decomposition. A really common one that's lots in chemistry is the thermal decomposition of calcium carbonate, which is CaCO3, and that decomposes to calcium oxide and CO2. This has an enthalpy change of about 175, and it's positive. So let's recap that really quickly. Two types of enthalpy changes. Do you remember what they are? I bet you do. It's endothermic and exothermic. And which way around do the signs go? So exothermic is negative and it gives out heat. Endothermic is positive and it takes in heat. So one more time, exothermic is negative, endothermic is positive. And how do we define enthalpy change? Well, the enthalpy change is defined as the measure of the heat given out or taken in during a process. Next, we are going to talk about a specific type of enthalpy, bond enthalpy. During a chemical reaction, some chemical bonds must be broken and some must be made. The energy to break or make a bond is known as the bond enthalpy. Great. Energy is needed to break a bond, so that's an endothermic process, whereas energy is given off when a bond is made, so that's an exothermic process. The enthalpy change of reaction is the sum of the individual bond enthalpies being broken and made during the reaction. Super. During a chemical reaction, we must determine whether the reaction requires more energy to break or to make the bonds. This will give an overall reaction enthalpy that is either positive or negative. And since bond breaking is endothermic and bond making is exothermic, more energy required to break bonds in a reaction will lead to an overall endothermic reaction, whereas more energy released when making bonds in a reaction will lead to an overall exothermic reaction. So do we remember the difference between bond making and bond breaking? So bond breaking is endothermic and bond making is exothermic. Now we are going to move on to talk about standard conditions. For many measurements, we record them under standard conditions, and this is true for enthalpy changes. We call it standard enthalpy change. Enthalpy is given with the symbol H, and enthalpy change are given with the symbol delta H. That's capital delta, it's a Greek letter, and it looks a little bit like a triangle. Well, it is a triangle, so it doesn't just look like one. A negative enthalpy change is one which gives out heat, and a positive one is one which takes in heat. You'll hear the term standard conditions a lot in chemistry. Chemists love it. And what are they chatting about when they say standard conditions? Well, it's a pressure of 1 atmosphere, a temperature of 298 Kelvin, and the reason we pick this is a substance most stable state will be at these conditions. So for water, it's a liquid, and for carbon, it's a solid, it's graphite. A standard enthalpy change is an enthalpy change carried out under standard conditions. There are two you need to know. You need to know the standard enthalpy change of combustion and the standard enthalpy change of formation. And the way these are written down, it's a delta, and then it's like a subscript C, and the H for enthalpy, and then a superscript theta for combustion. So delta C H theta. And for formation, it's delta F H theta. And the superscript theta signifies that it's a standard enthalpy change. So that's what that cute little symbol means. And maybe Google it and have a little look too. So standard enthalpy change of combustion. So that's delta subscript C, capital H, superscript theta. And this is the enthalpy change when 1 mole of a substance in its standard state burns completely in oxygen under conditions of 298 K and 1 atmosphere pressure. Whereas the standard enthalpy change of formation is defined as the enthalpy change when 1 mole of a substance is formed in its standard state from pure elements in the standard states under standard conditions of 298 K and 1 atmosphere pressure. Lord, I think if I say standard one more time, I'm gonna combust. So lots of standards in that definition, but learn those two definitions. They come up a lot as like one of the first or second questions on a paper. So they're good ones to know. And let's just review exothermic reactions to make sure we can consolidate that and you go away feeling confident and amazing. What do you remember about exothermic reactions? I want 3 things. Well, first things first, they have a negative enthalpy change. Next, they give out or release heat energy. And a really good example of this is combustion. Burn, burn, burn. And what about bond making and bond breaking? Do you remember those? So bond breaking, endothermic, bond making, exothermic. Now, are you guys ready for a cute little memory tool? Well, we can use the bendo-mexo as a nice little way to remember that bond breaking is an endothermic process, so that's bendo, and mexo, bond making, is an exothermic process, so bendo-mexo. And also this works because an endothermic reaction is one which requires more energy to break bonds, and an exothermic reaction is one which requires more energy to make bonds. So bendo-mexo, you're all welcome for that beautiful piece of revision material. That brings us to the end of this episode. I hope it was a useful one. Thank you for tuning in as ever. Good luck with all your studies. Keep up your hard work for your chemistry A-level, and let me know what you think of this episode, and catch you on the next one.